वेलकम व्यूअर्स। आज मेरे हाथ में एक पेन है फॉर एग्जांपल, और कोई भी ऑब्जेक्ट है, और इसको हमने वेरियस ऑप्शंस, इसकी जो वेरियस ऑप्शंस है, ड्रॉपिंग डाउन और थ्रोइंग हॉरिजॉन्टली और थ्रोइंग ऑब्लिकली और थ्रोइंग वर्टिकली अप, इसके बारे में आज चर्चा करेंगे, राइट? एंड दिस बेसिकली बिकम्स योर क्लास 11th फिजिक्स, द प्रोजेक्टाइल मोशन। अब ऐसा होता है कि बहुत सारे बच्चों को प्रोजेक्टाइल मोशन के बारे में डायरेक्टली पढ़ाया जाता है विदाउट कंसेप्ट ऑफ एक्चुअली व्हाट इज द मेन द की पॉइंट ऑफ द प्रोजेक्टाइल मोशन, राइट? एक्चुअली प्रोजेक्टाइल मोशन क्या है उसको डिफाइन करने से पहले हमको गैलीलियोस थ्योरम को पुनर करना चाहिए। गैलीलियोस थ्योरम एक थ्योरम गैलीलियो ने दिए थे। उनका बोलने का मतलब था कि टू परपेंडिकुलर motions are independent to each other. Two perpendicular motions are independent to each other. Two perpendicular motions are independent to each other. This is very important to understand, right? Why I am telling you this one? Suppose I project one particle in this direction. Suppose u is the initial velocity with which I project a particle in this direction, right? You can very well resolve it into its components, like the x component and the y component, your union of u cos theta components, and along the y axis it will be following uy or u sin theta components, right? So whenever you resolve any vector into two perpendicular components and you are talking about the motion, then they are independent to each other, and this saves your time to understand exactly how to derive a projectile motion or the oblique projectile motion. Befittingly, we would say the oblique projectile motion, right? Look at, let me rub this. Suppose this is your x-axis and this is your y-axis. And you project one particle from, let us say, from 0 coordinate, let us project one particle along this direction with one initial velocity u, and let this angle be theta. Then basically this can be resolved into the components as I told you. This will be your ux component and this will be u cos theta, and this will be your uy component and this will be u sin theta. Simple maths, trigonometric maths, right? Now if you project one particle here, the moment the particle comes under the influence of the acceleration due to gravity, moment you release it from here, immediately it will be under the influence of the acceleration due to gravity, which will be pulling it down, and the particle under the u sin thetas will try to take it upward. This will try to take upward, and u cos theta will try to take it horizontal, but the particle will move along this direction, right? That means when a projectile is projected from here, it has the x component, it has the y component, and under the action of gravity, as it is pulled down, this will be going to complete one projectile motion, and after certain time interval, it will hit with one particular range on the horizontal surface from where you have thrown. Obviously, it will go up to a maximum height also. It will go up to a maximum height also as you are projecting, right? So, this is very simple now to understand. If you understand Galileo's theorem that two mutually perpendicular motions are independent to each other. So this is very crucial to understand. Now you can utilize very well what happens to the particle at the highest point, what happens to the particle here, what happens to the particle at any point, right? So projectile motion can be well understood if Galileo's theorem of perpendicular motion is well understood. Am I right? So u cos theta is ux component you analyze. What you see here, along the x-axis, along the horizontal axis, there is no further acceleration. Or x component has acceleration ax tending to be 0. There is no acceleration pulling it along the x-axis. But the moment the particle is under the influence of vertical component, y component, it is always under the action of acceleration due to gravity. This will be acting as ay. Acceleration due to gravity will be acting as ay, or if you are taking the coordinates here, it will be negative in nature, because you have thrown the particle where the particle was tending to move upward under the influence of y component, and it was tending to move horizontal under the influence of x component. Now ax is 0. Acceleration along the x-axis is 0, and acceleration along the y-axis is the acceleration due to gravity. Am I clear? Am I through? So this is what is to be understood very well. Now at the highest point, what must be happening? You look at here also, the particle will be subjected to the component Vx and Vy, the final velocity Vx and the final velocity Vy. But look at the highest point. When the particle goes to this point, highest point, what must be happening here is the y component, Vy component, is ceasing to be 0. It is ceasing to be 0. So it is slightly acting under the action of x component. So it is pulled rightward. But the moment it comes to any other point here, now it has the x component and it has the y component of its velocity. It has its velocity vector at any instant result into the components x and y's, right? So this is to be understood very clearly for the projectiles, that they are ux is independent of uy. So when you apply Vy equals 0 and you try to utilize or find out the time of flight of the projectile, you can easily find out by applying the formula, like Vy Vy, three equations of motions. Come back to three equations of motions and utilize Vy is Uy plus Ayt. V equals U plus At. Like you write V equals U plus At. You can result it into two components now. Vy will be Uy plus Ayt. Clear? So this is so simple now that Vy is becoming 0. So put the value of Vy is becoming 0. And you write Uy. What is Uy? Is your U sin theta. U sin theta. And plus Ay, acceleration along the y component, is now the acceleration due to gravity which is acting vertically downward. So I will be writing this as minus g into t. That means 0 can be written as u sin theta minus g into this t I am talking now is, as I am talking about the highest point at which the projectile's y component is becoming 0. That time means half of the time of flight. Am I right? So can I write this as t by 2? Capital T by 2. So if this is clear to you, then the equation will tell you that u sin theta will be equal to gt by 2. And what is time of flight? What is the time of flight? The time of flight will be 2u sin theta upon g. 2u, let me write here, 2u sin theta, 2u sin theta upon g will be your time of flight. Not clear? Let me write. The time period t will be 2u sin theta upon g. So this will be your easiest derivation of what is the time of flight for the projectile. Where from you started, you look at, and if you are applying the Galileo's theorem correctly, then you will be getting very easily what is Vy. Putting the values, you will be getting it definitely. The time of flight will be 2u sin theta upon g. Right? Similarly, the final velocity along x-axis. If you ask me what would be the final velocity along x-axis, should I have this one? Yeah. Final velocity along x-axis. Suppose Vx I want to write same way, ux plus axt, u plus at, v equals u plus at. So Vx will be ux plus axt. But as I told you, acceleration along x-axis is 0. The acceleration along x-axis is 0. So this component will not play any role. So what will be your Vx? That will be always ux. So please keep in mind, in the oblique projectile, Vx is always ux. and ux is u cos thetas, right? So this is what is also one important concept to be understood for the projectile motion, right? So Vx is ux. Time of flight is 2u sin theta upon g. Now if somebody will ask you the height, the maximum height the projectile covers up, then also you can calculate from the second equation of motion, like should I rub this one? Yeah. The height of the flight, the maximum height of the flight h, it is like s equals ut plus half at square, h equals ut plus half gt square. This will be using acceleration. Here we are writing as g, right? And sign considerations you are taking, then you will be writing s minus g. So h will be ut minus half gt square. Now h is the vertical height, so we will be writing here obviously the y component of it. So uyt and half of gt square, because ay acceleration along y axis is your g with the negative sign. So we will be writing uyt minus half gt square. So you can put uy as u sin theta, t for the maximum height you are considering, so you can write this as t by 2 minus half of acceleration due to gravity with t square, right? This is your time, so t by 2 square. This is how you will be putting the time concept and the time of flight, as you talked about the time of flight 2u sin theta upon g. So half of the time of flight is u sin theta upon g. So u sin theta upon g can be put here, u sin theta upon g can be put here. That means if I put here u sin theta and u sin theta upon g, u sin theta upon g minus half of g with u sin theta upon g is square. This means it will be u square sin square theta upon g, u square sin square theta upon g minus it will be u square sin square theta upon 2g, u square sin square theta upon 2g. Look at here, 1g and g square, so this will be cancelled out. I hope I am not moving faster, right, for class 11 children. So u square sin square theta upon g square and g cancel out, so I am writing u square sin square theta upon 2g. That means the maximum height of the projectile. The height of the projectile can be easily calculated also as u square sin square theta upon g minus u square sin square theta upon 2g, means x square minus half x square type, right? This is the equation. So u square sin square theta upon 2g, u square sin square theta upon 2g. So height of the projectile height of the projectile will be u square sin square theta upon 2g. U square sin square theta upon 2g. Now, maximum height somebody will ask you, then you will be putting here the values. What will be the maximum value for this such that the height of the projectile will be covering maximum height? When sine component is there, you can analyze very well and you can put the conditions trigonometrically about when theta assumes 90s, sine square thetas, right, will be 1, then maximum height will be covered. Maximum height will be covered. Am I right? This is how the projectile motion is going to be simplified one after the other. That what is the time of flight, what is the final velocity of the particle at the highest point, what is the velocity at any point also we can calculate by applying the Galileo's theorem and the postulate. Similarly, the range of the particle can also be found. Maximum range of the particle can also be found as ux or u cos theta is not acted with one acceleration. So we can put here the maximum range will be what? The ux component multiplied with the time required for this flight, maximum time taken for this flight. So u cos theta into capital T. The range, should I write this one? Yeah. So the range of the projectile is nothing but ux into t. So range of the projectile will be found as u cos theta into t. But t is nothing but 2u sin theta upon g. So we can write this one as u square 2 sin theta cos theta or sin 2 theta upon g. So range will be u square sin 2 theta upon g. U square sin 2 theta upon g. Now you can put your conditions trigonometrically of when will be the maximum range of the projectile. Sin 2 theta. So when the sin value will be 1 or this value will be 90s, means theta should be 45. From here you can indicate theta is 45 degree, then maximum range will be covered. Like here you analyze when theta is 90, then maximum height. When theta is 45, maximum range. Got it? So this is how the projectiles, one after the other, all the concepts can be well understood if you understand exactly what is Galileo's theorem of two mutually perpendicular motion. So next class we shall discuss about other topics of class 11th physics. Okay, so good day.